I'm Gary Bland. This is our monthly LUG. Today, Roy Williams is going to be presenting on CodeSparta, a disconnected OCP deployment method. That's all I got. Roy, take it away.
Sure. So I'm sure the first question is, what is Sparta? So CodeSparta is some automation that was put together by some of our Red Hat consultants over on DoD, if I remember correctly. Basically, they were looking for a simplified method to deploy Openshift 4 into a disconnected or basically air-gapped AWS environment. So currently, CodeSparta only supports AWS. You can see here they are currently supporting commercial, GovCloud, C2S, and SC2S. But all of these other things are on the roadmap. I know they have been doing work recently on VMware, and apparently that's just getting close to coming out, but it's not there yet. So there are many moving parts to this. A lot of these things are basically pieces and components of automation have been wrapped into some container images, and I am no expert on exactly what they have done here. I have just learned how to use it. So with that, we'll jump into what it is, or rather how to use it. CodeCTL or codecuttle.io is where you'll find all of these instructions I'm looking at right now. Also, we have links to their GitHub, and there's, of course, additional resources there. So I won't read through the overview. If you do come here and look at this, you can, kind of read through what the various components of this are. We're going to jump straight into the user guide. So for our prerequisites, essentially we have to have AWS requirement or AWS environment that meets the minimum OpenShift requirements. We have to have all of the user provisioned base infrastructure up. But what I'm using is this Sparta dev kit because I started with an account that had absolutely nothing. What this deploys is a VPC and some basic subnets, some IAM roles, and a registry and a bastion server. And we'll take a look at those in just a minute. And then, of course, you need your keys for AWS. The next thing we'll need is the low side unrestricted prep node, which is what DevKit will refer to as their bastion node. They have that particular system set up that it can talk to the internet within that VPC, but nothing else can. So with this node, if you're not using DevKit, what you'll need to do is deploy something that's RHEL 8 and has roughly these specs. So T2 2XL works great. And then make sure that we have good DNS and whatnot, and at least 64 gigs of RAM, of storage, to make sure you have plenty of room to download all the content and operators if you want to do operators. And of course, this one again has to have access to the internet. This is where we're going to generate our bundle, as they refer to it, or pull in all of the content that we need from the internet that we're going to bundle up and then use that to take it over to our disconnected area. And of course, we'll need Podman installed because we're doing this again with some containers that contain automation. And then we'll need to get a pull secret from Quay, which you would need anytime you're doing an OpenShift install anyway. So jumping into it, if you want to play with this at your house, Sparta Dev Kit, we'll look at that real quick. Basically, you just clone down the Dev Kit project, and then you modify some variables, and this variables.tf. I have this system here is my dev kit node. This could just as well be your laptop or anything that meets those requirements and can talk to the internet or talk to AWS specifically. So variables.tf has your what the name of the SSH key you want your instances to use, the actual value of the SSH key, what AMI you want to use for CoreOS and for your Bastion. The registry it deploys is using CoreOS. The Bastion, of course, is just using RHEL 8. And then the VPC ID, the cluster name, and the base domain for the cluster. So once you have those things, basically just run this command, of course, replacing all the X's with your particular AWS keys and potentially changing the region to not a GovCloud region if you're doing this in your own personal commercial account. And that's that. What that will deploy is these two nodes in a VPC. Again, you can see this is the Bastion, and we'll be jumping in through its public IP address. And the registry node, while it has a public IP address, it is not listing on that at all. Because I tried to go to it directly, as you can see here, and that failed. So I had to jump through the Bastion to get to it. So with that, we'll jump back over to our low side bundle. So we went through the prerequisites. We have a VPC up. We have all the two instances that we need in it. So we're going to do the low side artifact bundle. So the first step is to SCP your SSH key from the system you're on, so presumably your laptop or your workstation, up to this Bastion node. You can see that I have already completed that step. And if you set these variables at the command line, it makes your life a lot easier because you can literally copy and paste everything from that point forward. All right, so all right. So the next thing you would do is you SSH in, which I'm already into it, so that doesn't matter. Then we're going to knock out some of our prerequisites. So we need to install Podman, which, as you'll see, Podman is already installed. You can see that we already have a bundle directory. And then we will run this. So what this command is doing is it says pull always, so it's always pulling fresh content. It is mounting the volume home bundle, so the directory we just created, to the container at root bundle. And we are running this container, coffer, in that particular version or tag. And then this is the config file that it's using to pull in the content. So we can actually take a look at that. And this is the YAML that basically defines what this is going to bring in. So here you can set the version of Openshift that you want to pull. You can select what version of the Sparta code or TPDK you want to use. You can also add in operators. So I'm going to kick this off, but we're just going to let it run in the background because I actually already have this stuff pulled down. But for the sake of showing you this, next thing you do is you go get your pull secret, which hopefully I'm already logged in. And conveniently, to get your pull secret, you can literally just click this link and it will have you log into your Red Hat account. Just copy the pull secret, paste it in, and you're off to the races. So the next thing you do after this finishes, you just go through and recursively chown the directory and all the content that lives within it. And then you run a DU to see how large that content is. So what ends up being in this bundle directory is essentially a tarball and I think one other file. But while this is running, we'll go ahead and jump over to the artifact walk. So artifact walk, what is the artifact walk? This essentially could be, this is one example of how you can get the content from the low side, the internet connected system, to your disconnected environment. You could use S3, you could use SCP, you could use rsync, you could burn it to DVDs and walk it over. You could use a thumb drive, external hard drive, whatever you prefer. In this particular example, because we can communicate between the systems, we're just using rsync. So we literally rsync, showing the progress so we can monitor it. We're rsyncing the bundle directory to the home directory of the registry node. So as soon as that finishes, we then SSH over and then extract that tarball from the bundle directory. So I've already done that. And what we can see over here is that we've extracted this into root. So what that leaves us with is in root, we have Cloud Cuddle and we have platform. I don't have tree installed, so I'll just do it this way. So under platform, we have, several directories worth of stuff. The important ones are IAC, which is all of our infrastructure as code that was pulled down as part of the bundle. And we have our mirror, which is where all of our images and operators and things live. So let's jump over to the high side deploy. So the high side deploy, this assumes that you have already SSH'd to your registry system. The first thing you do is you sudo to root. So we've already done that. The next thing you do is you CD to Cloud Cuddle. And of course you can copy and paste this and it'll just run the script. I've already ran it. So we'll take a look at it, see what's going on there. Essentially, it will generate an SSH key if that's not already been done. And then it kicks off some pods with Podman. It's not a whole lot going on there. And then after that has finished, we exec into the conductor pod. So this is where things start to get interesting. This is the environment where we will actually do the deployment. So the first thing we have to do is just modify these cluster vars. So please ignore any of that. Notice the VPC name, the base domain, VPC ID, which you would get from the VPC that was created whenever you create it or using DevKit, the region you want to deploy to, your keys, the CoreOS AMI, and your subnets. These are the private subnets specifically. And then the next thing we do is we kick off the automation. So the automation itself only takes like 5-10 minutes. It doesn't take too long at all. And then it will exit and we will sit and watch for all of the operators to come up for Openshift 4. And we're basically just going to watch until our ingress operator comes online. Then we're going to go out and grab the route for it and go update our DNS, because apparently, while AWS exposes internal endpoints for most of their services, Route 53 does not have an internal endpoint. You have to go to the internet to get to it. So because of that, we have to go manually do this one step. But all it is just making a DNS entry, or in the case of this particular environment, because I've already done this a couple times, we'll just be updating the DNS entry. And then we'll be able to watch the rest of the operators come up, and then we'll be able to get to the console. Any questions so far?
Not for
All
me.
right, lovely bunch.
Yeah, not 100% about your presentation, just a curiosity thing. Is this your personal AWS account that you're using here, or are you able to leverage something through consulting or somewhere else?
I was able to get something through consulting.
Okay.
Yeah, so we're actually deploying to GovCloud right now, which you probably noticed from the region that we're deploying in.
I didn't notice. I wasn't paying attention at all that it said GovWest or that there was a key in there.
All right, let's go over here and see what we got going so far. Still nothing spun up yet. That's what this step here is doing, is deploying our bootstrap and our masters. So the first thing we'll see come up is, of course, the bootstrap and the masters. Bootstrap is used to get the masters up and going, and then from there it will build out the worker nodes. Basically, what this is doing is just a big wrapper around Openshift 4 UPI, so a user provisioned install. All right, now we can see that the bootstrap and the 3 masters are coming up. All right, so all the automation finished. So the installer has completed running. We can see everything either changed or was skipped. Nothing failed. So now we will start watching for the operators to come up. First here, it will say that it doesn't have a route, or rather it can't communicate with the API as things start to initially come up and start responding. So it's not uncommon to see this for a little bit. But if you try this at home and you don't see this change after a few minutes, then you probably have something not right with your DNS, or something else has happened that prevented your bootstrap and or masters from getting their ignition. And this part is definitely the longest couple of minutes of your life. And there we go. We're starting to come up. At least on one of the nodes. So this is the part where we get to watch paint dry. You may have noticed that it may take 30 to 60 minutes for this particular piece to finish. I do not have a fast forward button, unfortunately, but it does take every bit of at least 30 to 45 minutes as a minimum. So while we wait on this to start making some progress, I will point you guys over to a specific part of their GitHub. So of course the CodeSparta organization is the where they have all of their code. And this is where the link from CodeCuddle will take you. So here we have basically all of the components that make CodeSparta. Specifically, Sparta is the primary. The other are just the components. And then we have our dev kit, which is, again, what we use to deploy the VPC. Within dev kit, there's a docs directory and a tips file. Here, you will find two very interesting and helpful things that you can run. The first is Shuttle, which is a package that you can find just with DNF if you're on Fedora. Source is available if you want to install it on Rail. It's also available in EPEL if you want to install it on Rail. And I'm pretty sure it was packaged up for Ubuntu as well. But essentially, the only thing that this requires is Python to be installed on both the system running it and the system you're wanting to connect to on the other end. And then you just put together this command that basically tells it to SSH with your PIM file or your SSH key, where your SSH or what you're connecting to, and then the address that you want to exclude, which is itself, and then the network that you want to be able to route to. And this flag will also forward your DNS across that. So what this allows you to do is essentially it works as a poor man's VPN. This allows you to be able to route to things that are within this VPC, which is otherwise not something you can communicate with because there's nothing touching the internet for you to access. This works quite well. However, there is a caveat with this. If you're on a system that uses DNS mask and Resolve D, you basically have to disable DNS mask, and there's some documentation here for how to do that as well. The other thing down here is basically just a registry browser. So this is what it looks like. Basically just gives you a graphical representation of what is in your registry. So you can click through, make sure all of your images are there where you expect them to be, make sure your operators are there if you've imported operators, and so on and so forth. So to run that, basically you can run this on, I have this running on the Bastion, but you could theoretically get it to run on the registry server as well. The big thing is you just have to make sure you use the actual IP and not localhost if you're running it on the registry. So this will be the IP of your registry. Make sure you're mapping the port of the container to an unused port on the host. And these are the default credentials that are used. And this is the image that it will pull for the registry or for the registry browser. So, oh, you can see over here, this is the, forgot to jump back over to this. This was the bundle. So the content collection took 8 minutes and 41 seconds for it to pull all of the images needed to required to do the installation of Openshift, and the infrastructure as code from CodeSparta to basically do all of your automation and get that over to your disconnected side as well. So you can see here, basically this is the same command, just with the IP changed out to reflect the private IP of my registry server. So we got that up and running now. And then we can see I'm already running shuttle over here. So again, just I went ahead and set my variable so I could copy and paste this, make it easy. And that allows me to be able to do this. I could just as well use bastion.roy.redhat.io, and it would also resolve. So now you can see various images that are in here. Now, this, if you did this on your own at home, just following these instructions, this is going to look quite a bit more sparse, because I have operators installed in here as well. I believe the only thing you would have is the Cloud Cuddle and this root namespace.
I got distracted for a minute. I may have missed something. What different types of registries are supported?
So the automation is just doing a standard Docker registry. There's not really any pluggable registry that you can say, I want to use this type of registry internally. I suppose once the content is in on your registry system, you could spin up some other container image, I suppose, to host that content. You just have to make sure that, you know, the file structure is still appropriate for whatever solution you want to use. All right, so looks like we're starting to have some things come up. So let's go see if we can pull this information yet.
And so does this deployment only work with 4.6 and 4.7?
I'm not sure if there's a minimum requirement. I have tested it with 4.6 and 4.7. So I'm not 100% sure. I didn't see it called out in the prereqs, so I assume it would possibly work with older versions, but have not tested that. Sorry.
Oh, sorry. I said so most, but it would definitely be 4x versions, not 3x versions, correct?
Correct. Yeah, this is specific for OpenShift 4.
So who all's deployed any version of OpenShift?
Me. I'm not the only one, I don't think, am I? Keith?
Nope, I have not actually deployed it yet.
Oh. Ray has. He's not on here.
No. So I've tried it a few times in the past in my home lab and ran into several different issues. One, of course, being internet speed. The other was, I think I made some of the disk speed checking checks weren't too happy with my Synology speeds, even though, I mean, it's fairly robust, but I think it's still aired out during the install because of that. So
Or were you using Rev?
So I've tried multiple things. There were more. Um, there was more requirements using Rev when it was trying to deploy the different virtual machines. I also tried to do one that a Red Hatter out of England wrote that was just using KVM, and I had nothing but network problems with that. And it seemed to be something with the super micros because nobody else was having the issue but me. I don't know how many other hundreds of people were pulling that Git repo, but it was always networking errors.
Yeah.
It would deploy all the VMs
I've
and then crap out during networking.
Yeah, I've tried to deploy to Rev and VMware, and Rev, I was doing hyperconverged Rev. Would not recommend. That did not go well. I mean, hyperconverged Rev works fine, but deploying Openshift to it, not so well, especially when you only have 1 gig NICs, and that makes storage extra slow. So then more recently, I installed ESXi and vCenter, and that seems to be much more friendly. I also added some SSDs, so that helps. And I've gotten mostly deployed, but because I have older hardware, it makes it kind of an extra difficult to work with VMware. And also, apparently, there's a bug with 4.7 and VMware that something about the virtual machine hardware version causes network issues or something of that nature. I was just reading about that the other day because it's what we're deploying to on my customer network.
Yeah. Well, I got it to work on Ravi, but it took me a day and a half to get it installed, Roy. And then every, probably 30 minutes, etcd would die because the disks were so slow. That was with 4 gigabit NICs bonded together, so I had a 4 gig connection. What I ended up doing was just buying a 2011, 2012 server off of eBay and sticking that in my basement. And I made that a Rev hypervisor, but it's local host with local storage. So there's like 3 disks in there, and I just did that as a RAID 5, and it seems to be running solid on 4.6. I installed 4.4 and 4.5 on it. I upgraded that to 4.6, and then I just tried a fresh install from 4.6 as well. So it's working well now. And the LPI installation even created the storage for persistent storage volumes.
Gotcha.
Everything worked great there. It created the overt CSISC storage domain.
All right. So as you all probably saw, the ingress operator finally had a version number and said it was online and available. So we run this OC get service command and basically use awk to only get the ELB that we want. And then for the instructions, if you just click this URL, it takes you to the Route 53 for your VPC. And then we want to either create a CNAME that is star.apps.theclustername.domain name. Or in my case, because this already exists, we'll just edit this record and make sure we have the correct info in here. So we'll delete out what's there. Set in, save. And now what this will allow is, this is of course our wildcard domain, and the console and everything sits behind that wildcard domain now. So we have to make sure that this is available before we can get the console to actually come up and be available for us to access it. If we were to forget to do this step, what you would have is your console and your authentication would end up being degraded and never become available, at which point you can still go add this record or modify this record to fix it. You just have to go in and kill off some pods to make them restart, specifically the ingress, the console, and the authentication, until finally everything is up and happy. And you can see just in the time that I've been discussing that, our console already went from not being available to available. And then the last thing, the thing that usually takes the longest, is the authentication piece. So we'll wait for that to go true, and then we should be able to log in. All right, so we can see that we can already get to the console. We're just not going to be able to log in yet. Now, if you're doing this start to finish, I would say it roughly takes between an hour, hour and a half, start to finish. If you're going through copying and pasting, making sure you're using the variables and things. If you want to go through and, maybe play with customizing that Sparta.yaml file to include some operators or something of that nature, and you want to understand every single step, it'll take a little bit longer. But once you get it down, you can certainly do a full deployment from start to finish, nothing in AWS, in roughly an hour. And I've found this to be quite useful whenever I need to go quickly spin up a cluster and test something.
And this is a new active project that people are contributing to and enhancing and making better.
So, quick question here, though, too. That tar file actually has all the container images in it required for Openshift and throws that in your local registry.
Yes.
So there is going to be some speed getting that transferred up to AWS that you've got to also account for.
Yeah. So the bundle without operators is approximately 12 gig. So yeah, that adds, I think it was like 10 or 15 minutes, but of course it's going to be 100% based on whatever your network capacity is. So in my case, when I've demoed this or done this in the past, I've been doing it from one EC2 instance to another EC2 instance in a separate VPC. So there's not a whole lot of bottleneck there. But trying to do the same thing from, a workstation to AWS may be a much longer process.
Okay. Yeah, that's what I was getting at, because I was thinking about like Gary's use case. If he downloaded this stuff at home and then tried to do it, it with that hour to hour and a half time frame quote you had, that's only accurate within super fast networks.
So if Gary wanted to do this, he could still get it deployed within an hour to an hour and a half, as long as he does all of his content collection and everything in an AWS environment that allows that instance to talk to the internet. So basically exactly what I'm doing right now, where I have literally everything running in AWS.
I'll ask while we've got downtime. So I know, Roy, you used code ready containers. at one time in the past, because I saw that in your browser history. When you pulled down, there was a CRC in there. Maybe it was for the Open Innovation Labs thing where we had to use it. But that's like your cheap OpenShift. Well, I was wondering if Gary asked if anyone on here used OpenShift or installed it at home or anything like that. I'm asking the same question for either code ready containers, or if you're happen to be a Windows user or Mac user, Docker desktop with straight up Kubernetes.
I haven't played with either of those, or at least not knowingly.
I tried to deploy a code ready machine in Rev, and I found the documentation, our documentation, to be rather lacking, or maybe it's just I'm not a developer and don't understand some of what it was asking for.
Yeah, it's not too bad to deploy. I did it as KVM on a Fedora box and also did it on a Mac. I would call it OpenShift Lite, or a mini shift version almost of OpenShift. So it was cool where the commands still worked and it gave you a very similar OpenShift console. But no, I was just curious. And then recently, since I've been delivering everything with this MacBook, I'm running Docker Desktop and Kubernetes, and I installed the Kubernetes dashboard to make it OpenShift-like.
So as you guys probably saw just a second ago, authentication filing went true. So from the directory we were in, which was root platform IAC Sparta, we cd back 2 directories and to the secrets directory. You can probably guess what the secrets directory holds. Inside that directory, we want to go to cluster, and inside there, we want to go to the auth directory. And inside the auth directory, we will find the kubeconfig and kubeadmin password. So we'll grab the kubeadmin password, as I've done there. Username kubeadmin. That does not look like that's what I wanted, so let's try that again. Bitwarden is freaking out. But now you can see we have a cluster. Now there are some additional steps that you have to take if you want to import operators, because if we go to the operators right now, because we are not connected to the internet, you will see that the operator hub is not found. But there are some additional steps that can be taken to direct that to a local registry that contains operators, and then you can install any of the disconnected supported operators. And that is that's pretty much that. It's, as you can see, it's pretty simple to follow. They intentionally made the instructions very copy and paste user friendly. The biggest gotchas are making sure that you match up your variables here to what you have for your VPC. So if you use DevKit to deploy, make sure essentially your domain and your cluster name or VPC name match in the variables.tf file and the clustervars.yaml. Otherwise, you'll end up with DNS issues whenever it tries to provision your DNS for Route 53. And that's pretty much it. It really is as simple as it seems.
That's awesome. Way easier than it used to be.
Yes, at least for AWS. So Anyone have any questions before we wrap up? All righty then. Well, if you guys have any questions, you can email me, roywilliams@redhat.com, and be happy to answer your questions.
Cool, man. I really appreciate it. I hope everybody got something out of it, even if it's not, your primary job deploying stuff like this, which it kind of looks like most of the people in here are will be doing this very soon if they haven't already. So yeah, reach out if anybody has any questions, and thanks again. I think Keith is going to be doing next month's LUG on container registries. So look for the website to change with updated information in there. I appreciate it. Thank you all. Have a good evening.
Cool.
Thanks, Roy.
Yep. Thanks, y'all.
Thanks, Roy. Thanks, Gary.
Yeah, man.
Thanks.